Hi fellas, this is Chemaddcts again with the solution. Welcome back to another video tutorial. So we're gonna proceed the previous question. Okay. So this would be the second part of that question. So if you have missed the first part, please click the link that is given over here. So I will put a link to the first part over here. Okay. So please watch the first part and then come back to the second part. Okay, without watching the first part it would be hard to understand the second part. Okay, to understand this second part it would be hard to understand this second part. Okay, so I hope that you have watched the first part. So let's get back to the topic. Okay, so now what we gonna do is we're gonna carry out the experimental method for this question. Okay, so now we're gonna double the concentration of propanone. So let's see what would happen if we double the concentration of propanone. Well, let's at first see the question for this. Let us first see the question. Okay, so in here the rate equation is given. Okay, so what further experiment could be done to show that the order of reaction with respect to propanone is 1? Okay, to state the effect of this change on the graph. So as you can see that there are two parts of this question. So the first part asked us to find the method for finding the order of propanone is 1. Okay, so this would carry 1 mark. And the second part of this question asked us to find the shape of the graph or the effect that it has on the graph. Okay, for that it has second mark. Okay, 1 mark. So in total we will have 2 marks for this question. So the first part is for explaining the method for finding the order of propanone. Okay, and for the second mark will be for the effect of this change on the graph. Okay, so what would be the graph, how we should interpret the results of this experiment on the graph. Okay, so for that we will get 1 mark. So okay, 1 mark, not minus. So for total we will get 2 marks for this question. So this question would have two question. This question would have 2 marks for this question. Okay, so let's get back to the solution. Well, now we're gonna carry out the experimental method. We just gonna double the concentration of propanone. Okay, we just double the concentration of propanone. So let's see what would happen if we double the concentration of propanone. Okay, so the rate also becomes double. So it is observed that the rate also becomes double. So here we can double the concentration of propanone. Now it is observed that the rate also becomes double. So now let us study the rate equation for this uh, experiment. So it is observed that here we have varied the concentration of propanone is varied, but we have kept these two concentration constant. Okay, keeping these two concentration constant. So we have kept the concentration of hydrogen ion and iodine constant, but we have changed the concentration of propanone here. Okay, so this is unchanged, these two are unchanged, this is unchanged, and the concentration of propanone is varied here only. So it is seen that if we have varied the concentration of propanone, so the rate also changes. So if we double the concentration of propanone, it is also observed that the rate also become double. So if we double the concentration of propanone, the rate is also been doubled. So here we can see another relationship, that is rate is directly proportional to the concentration of propanone, CH3COCH3. Okay, so rate is directly proportional to the concentration of propanone. Okay, so rate is directly proportional to the concentration of propanone here. So from the rate equation, we can see that since rate is directly proportional to the concentration of propanone, doubling the concentration of propanone also doubles the rate. Okay. So since rate is directly proportional to the concentration of propanone, so therefore the order of propanone would be 1. So as we can see that this also matches with the condition of the rate equation. Okay. So since rate is directly proportional to the concentration of propanone, so the order of propanone would have 1. The order of propanone in this rate equation would be 1. So as you can see, this is the order of propanone. Okay. Order. Okay. So now if we plot the graph of concentration of iodine against time, just as before, okay, just like before, we're gonna plot the graph of concentration of iodine against time. So let's see what would happen. So now let us do a little bit of graphical analysis. Okay. So we have plotted the result over here. We have monitored the concentration of iodine against time. So it is seen that a graph of straight line with negative gradient is obtained. So here the gradient would give us rate. So gradient is equals to rate. So in here it is, since it is a straight line, so the gradient would be constant. So for a straight line the gradient would be constant, as you already know. So the rate would also be constant. Since gradient is constant, the rate would also be constant. Okay. So rate is constant over here. So but there is a difference. Okay, there is a difference. So there is a difference. So let's see. The graph shape would be similar to the graph of previous experiment, as you can see, but the only difference would be the gradient of the straight line. So the only difference here is the gradient of the straight line. So in here let us compare the first experiment and the second experiment. Okay, the first experiment is the one that we have carried out in the previous tutorial, previous video lesson. Okay, now we are dealing with the second experiment. So now let us compare the previous experiment and second experiment. Okay, now the experiment that has been carried now, the second experiment is the experiment that we have carried now, and the first experiment is the experiment that we have previously done, that is previously done. Okay, so this is previous experiment, and that this is now's experiment. Okay, so so in here we have seen that the first experiment would be So we can see that second experiment would be steeper. The gradient of second experiment would be steeper than the first one. Okay. So the only difference would be the gradient of the straight line. Here the gradient of this straight line, okay, the gradient of this straight line is steeper than the gradient of this straight line. Okay. Here the gradient of this straight line would be greater than the previous one. Okay. Here, suppose this gradient is G1 and G2. So G1 would be greater than G2. So ultimately we can see that G1 would have greater rate than G2 or R1. R1 is greater than R2. This would give, suppose this would give us the rate as R1 and this would give us the rate as R2. Okay. So the R1 rate for this experiment would be greater than the rate for this experiment. So I hope that you have understood. So if you are still confused, let me know in the comment section. Okay, I'm gonna help you out. So since the concentration of propanone is now changed, we can also plot concentration of propanone against time graph. So let us see plotting concentration of propanone against time graph. Okay, now plotting the concentration of propanone against time graph. So here it is important to mention that this thing is called concentration of propanone. Okay, so this is concentration of propanone. So if we plot the concentration of propanone against time graph, we will obtain a graph like this. Okay, so if we look at the half-life of the concentration of propanone, okay, so if we calculate the concentration of the half-life of concentration of propanone, we will see this. So the half-life is the time taken for the initial concentration to become half. Okay, so this is the half for this one. Okay, the concentration that becomes half is this one. So here we get the T1 for this one, and here the second half-life is from this to this, so we get T2. So in here the first half-life would be T1. Okay, and the second half-life would be T2 minus T1. Okay, most of the students consider T2 as second half-life, but it isn't true. It is not correct. Okay, so we should minus T2 with T1. So here we can see that this length is called the first half-life and this length is called the second half-life. Okay, from T1 to T2. So the second half-life should be from T1 to T2, not 0 to T2. Okay, so 0 to T2 is the total time, and the time from T1 to T2 is the second half-life. So this is the first half-life and this is the second half-life. Okay, so if you have noticed, here the half-lives are constant. Since the lengths are constant, and here the half-life is constant. So here we have learned another point from here is that for first order reaction half-lives are constant. Okay, half-lives are constant. Okay, so suppose the half-life, the first half-life is say for example is 15 seconds, and the second half-life is suppose is 20 seconds. So it is not the second order. Okay, it is the first order. Since the half-lives are not doubled, So this should be the first order reaction. So in other words, we can say that half-life may be virtually constant. Okay, so the half-life can be constant or almost constant. So here the half-lives are almost constant, so the values are close enough to each other. Okay, so here the here the time is not doubled. Since the time is not doubled, so the reaction is not the second order reaction. For second order reaction, the half-lives must be doubled each time. Okay, for first half-life it is 15, second half-life would be 30 seconds, third half-life should be 45 seconds, just like that. Okay, so for first order reaction, the half-lives are constant. Here we have learned another thing is that for first order reaction, half-lives are constant. Okay. If we look at the half-life of the concentration of propanone is constant, almost constant. Okay. So now let us get back to the question once again. So now let us write the answer for this question. Okay. So in here, concentration of propanone is being doubled. So this means concentration of propanone. The concentration of propanone is being doubled, the rate also becomes double. Okay, since rate is directly proportional to the concentration of propanone, then it is the first order reaction. Okay, this is for the first mark. So if we explained this much, we will get first mark. So the explanation for the first mark is this one. Okay, so the for first mark, if we write up to this, okay, if we write up to this, we will get first mark. Okay, for explaining this thing. So concentration of propanone is being doubled, rate also becomes double. So rate is directly proportional to the concentration of propanone, then it is the first order reaction. Okay, so for the second mark is this part. This part is for the second mark. So this is for the second mark. So then we will plot a graph, and the graph would be a straight line with negative gradient. The gradient would be steeper than the previous one. It is observed that gradient also becomes double. Okay. Then we will plot a graph, and the graph would be a straight line with negative gradient. The gradient would be steeper than the previous one. It is observed that gradient also becomes double. So for this we will achieve second one. Okay. So this is how we're gonna solve the answer for this question, for this particular question. So fellas, I hope that you have understood the question as well as the answer. So if not, please let me know in the comment section. I'm happy to help you out. Okay, so that's it for today. Peace with chemistry.